Hello and welcome to this video for Chemistry 20 in the Stoichiometry unit. We are going to learn how to do stoichiometric calculations that involve gases, as well as kind of putting all of the stoichiometry formulas together that we've learned so far. So when you have gases that are not at a constant temperature or pressure, or you have a mass given and you're given temperature and pressure and you're looking for volume, for example, you're going to be using the formula PV equals nRT, okay? That is the ideal gas law formula that we learned in the gases unit. So your steps are still the same as follows. We're going to start with a balanced chemical equation, including the states of everything, writing down all the information given, labeling the wanted and given in our question. Then we're gonna, like before, find the moles of the given species. Now, how you're gonna find it, like I said, I'm not just gonna show you today's formula, which is PV equals nRT, but also a review of the other formulas that you could also be using in these questions. So if you're given concentration and volume, you're going to find N with C times V. If you're given mass, and you can always calculate molar mass from the periodic table, you're going to find N with mass over molar mass. Or now, if you have gases, pressures, temperatures, volumes, and so on, you're going to find moles with PV over RT. That's the ideal gas law formula rearranged to solve for moles. Okay? So that is finding the moles of your given. Again, I can label this as N of my given. Now we can move on to step 3 and find the moles of our wanted species using our formula moles wanted equals moles given times the balancing coefficient in front of the wanted substance divided by the coefficient in front of the given substance. Okay, so that's why, like I said in step 1, you want to identify or label what is the wanted with a W and what is the given with a G, so that when you get to this step, you know what those coefficients are. Then last, you're going to find whatever the final answer is that you're looking for. You might be looking for mass, you might be looking for concentration, you might be looking for volume and you have concentration, or you're looking for volume and you have pressure and temperature, or you're looking for pressure, right? You could also be looking for temperature, that's not on there, but rearranging any of those formulas that we've learned so far in Chem 20. So our main formulas for this unit are PV equals nRT, and then C equals N over V, and then N equals mass over molar mass. So those are our 3 standard units that we're using, other than the moles wanted equals moles given times wanted over given. Those are the 3 standard units that we're going to, or formulas, sorry, that we're going to be using in this section for stoichiometry anytime you're doing a stoichiometric calculation. Okay, let's look at an example. You have propane. Now you wouldn't be expected to know what propane is. I would tell you what that is. It is C3H8 and it is a gas, I believe, at room temperature. It's burning in a barbecue. So burning, that is our reaction type. This is a hydrocarbon. So when hydrocarbons burn, remember they're reacting with oxygen gas. And the products are always CO2 gas and H2O gas. Okay, so we have a reaction in gases. It is asking us what volume of oxygen, oh, balance, don't forget to balance the reaction. We have 3 carbons in our propane, so I'm going to make 3 carbon dioxides. I have 8 hydrogens in my propane, so 4 times 2 in my water molecules make 8 hydrogens. Then I add up the oxygens on the product side. There's 6 from the 3 carbon dioxides and 4 from the 4 water, so there's 10 on the product side. So 5 times 2 on the reactant side will give me 10. Okay, so we are being given, and I like to make a chart out of this, we are being given the mass of the propane, 300 grams, and we want to find the volume of the oxygen. Now, remember the law of combining volumes video that we did in the last lesson? If this question gave you the volume of propane, you could just multiply wanted over given to find the volume of oxygen. However, you're not given that. You're given mass. Okay, so the only thing you can do is the 4 steps that we have. We're going to find the molar mass of our propane. So that's 3 carbons, which are 12.01, plus 8 hydrogens, which are 1.01. So that gives us a molar mass of 44.11 grams per mole. Okay, so I'm going to find the moles of my given with mass over molar mass. That's my second step. So 300 grams divided by 44.11 grams per mole. My grams cancel and we will get left with moles of our given. So 300 divided by 44.11 is 6.80 so on moles. Now I can use that to find the moles of my wanted. The moles of my wanted would be 6.80 so on. Remember, you're not rounding this answer. You don't have to write the full answer on your paper, but I always write ... reminding myself there's a full number here that I need to use in my calculator from one step to the next. Okay? My wanted over given is 5 over 1. In front of my wanted, there's a 5. In front of my given, there's a 1. So when I do that, I find the moles of my oxygen, which is my wanted, is 34.0 so on moles. Now, what other information do I know about the oxygen? I know that it is at SATP conditions. So that means the temperature is 298.15 Kelvin. Remember, for the PV equals nRT formula, you need your temperature to always be in Kelvin, and the pressure is 100 kilopascals. Okay, we also know R. Remember, R is a constant, 8.314. The units are complicated. They're kilopascal, liters over mole Kelvin, but you don't really need to worry too much about the units unless the question's really asking you to show the units of them. Okay, so if I want to solve volume and I have nRTP, right, I'm going to use the formula PV equals nRT. And I'm going to solve for volume. I need to rearrange both sides by P to get P to cancel. So volume is nRT over P. Okay, so my N, again, I need to use that unrounded value that we got. R is 8.314. T is 298.15 Kelvin. And pressure is 100 kilopascals. So if you put that in your calculator, 34 times 8.314 times 298.15 divided by 100, we get an answer of 842.94 so on liters. Looks like, go back at the question, there's 3 sig digs. So cutting it off at 3 doesn't cut the decimal, so we don't need to put it in scientific notation, but we are cutting off a 9, so it will round the last digit that we keep up. So the final answer would be 843 liters to your proper sig digs. Okay? And I believe that is the only example in this lesson. So hopefully, there's some sound effects here. Hopefully, that all makes sense. This is just a little summary again of your steps for stoichiometry. Again, looking at writing your balanced equation, law of combining volumes if you're just dealing with volume of one gas to another, or finding moles if you're given, then finding moles if you're wanted, and then finding whatever the final measurement of your wanted is. Okay? So that is stoichiometry. All the steps for all the different stoichiometry calculations, whether it's mass, which we call gravimetric, solution stoichiometry, where it has concentrations and volumes, and gas stoichiometry, whether you have the same temperature and pressure or when they change. Okay? Thank you very much for watching this video.